In this lesson, you're going to learn about the application and or the use of the standard deviation, particularly as it relates to the normal curve. Before we do that, though, how about an Aggie joke? Why don't Aggies eat barbecue beans? Because they keep falling through the holes in the grill. Kind of the unfortunate thing for you guys is that I don't know if you're laughing at these or not, so I'm going to assume that you're laughing at them, and I'm going to keep telling them. I think it's kind of fun to make fun of ourselves. All right, so let's look at the standard deviation and the normal curve. For this set of data, we've identified that the mean is 70 and the standard deviation is 8. I've drawn it out there for you. And let me have you write down a few notes about this before we get started talking about the rest of that diagram. But the normal curve is symmetrical, meaning what you see on the left-hand side is what you see on the right-hand side. As an example, think back to 3rd or 4th grade when you wanted to give your sweetheart a Valentine. You went home, found a piece of pink paper, folded it over, maybe drew half of a heart, but then you cut along the lines, and when you opened it up, you had a symmetrical heart. So this is kind of the same concept. If we folded the left half over onto the right half of a normal curve, they would be identical. A normal curve is bell-shaped, not too flat, or not too peaked. Also, the mean, median, and mode are equal and in the middle of the distribution. So there you have my at least hand-drawn picture of a normal curve. What the normal curve does demonstrate is that as you move further from the mean, you do expect to see fewer and fewer observations because the normal curve drops down toward the horizontal axis. Although you typically won't see it in pictures or depictions of the normal curve, there is an understood y-axis or vertical axis that does represent frequency. So remember, the highest point in the normal curve represents the fact that more scores are there, which here in the normal curve they're in the middle, and that at lower points on the normal curve, within what we will call the tails, there are fewer and fewer scores represented. So for example, if we were talking about height, most people are about average height, meaning they're in the middle of the distribution of height scores, with just a few really, really short people or just a few really, really tall individuals. So the most frequent heights would be in the center of the distribution, and then fewer and fewer really short people over on the left, or fewer and fewer really tall people over on the right. Now, another great feature of the normal curve is that it allows prediction of the number of scores within specified regions. So if a phenomenon is normally distributed, and again, that's our assumption when we're working with most of the things that we'll be measuring in the social sciences, what we do know are these things. 50% of the scores are above the mean and 50% of the scores are below the mean, because again, the mean, median, and mode are right in the middle. So 50% above, 50% below. And that 68, I'm going to be very specific here, 68.26% will be between the mean and 1 standard deviation. So within the mean and 1 standard deviation below is 34.13, same number at the upper end, and so collectively this is 68.26% of the curve. What we also know is that 95.44% will be between the mean and 2 standard deviations. So again, as we work our way out to the next standard deviation below the mean, another 13.59% are there, and then one more standard deviation above the mean, another 13.99 or 59%. So again, if we're talking about the normal distribution, something that is normally distributed, 95% or 95.44% of the scores will be between the mean and 2 standard deviations above and below the mean. So this would be x bar plus or minus 1 standard deviation. This is x bar plus or minus 2 standard deviations. And then if we keep moving out on the normal distribution, another, and we're going 3 standard deviations out, 2.14% here, another 2.14% here. So specifically, 99.72% of the scores are between the mean and 3 standard deviations above and below the mean. So again, this would be X bar plus or minus 3 standard deviations. All right. So what I've done for you in this picture is, again, for this set of data, this is a fictitious set of data. The mean was 70, so we're going to put that right in the middle, and then we're going to actually identify the raw score that is 1 standard deviation above the mean. So that's simply 70 plus 8 is 78. And then we go 2 standard deviations above the mean. 78 plus 8 says that a raw score of 86 would be 2 standard deviations above the mean. And then we add 8 to that. We have the raw score at 3 standard deviations above the mean. Then we work our way down. 70 minus 8 tells us that a raw score of 62 is 1 standard deviation below the mean. Subtract out 8. A raw score of 54 is 2 standard deviations below the mean. And then 3 standard deviations below the mean is a raw score of 46. So you've got the row of raw scores at each of those points. And then I actually identified where the mean is, and then the actual 1, 2, or 3 standard deviations below the mean, or and above the mean for that matter. All right, just a couple other things to remember. The normal curve has predictable features, meaning if it is normally distributed, we can use sample statistics to estimate how many scores are in a population fall within a specified region. Okay. A final note is that the normal curve is considered to be something called asymptotic. ASYMPTOTIC, asymptotic. What that means, and I did an okay job drawing here, is that the tails of the distribution approach the horizontal axis, but they actually never really touch it. So asymptotic is another feature of the normal distribution.